Well, hello everyone. This is Dr. Stan Gross. I'm the president and co-founder of Sano Global Nutrition. And I wanted to start the training session. I thought, let's start with our flagship product, the original flagship product, because I'll tell you, there's a lot of research and there's a lot of work that's being done behind this, continuing not only here, but in Southeast Asia, now in South and Central America, and also in Europe. So we're very excited about some of the results we're seeing, and I wanted to give you a little bit of training in this so you know a little bit more about the product. So here we go. So what's the purpose of Immune One? I mean, what does it do inside the body and who can benefit from it? Well, as the name implies, it affects the immune system. So how is our immune system compromised? Well, obviously we know about viruses and we know about bacteria. We know about carcinogens, things that cause cancer. We know about pollution. We know about parasites. We know about fungus. Toxins are everywhere. We're developing a toxic planet, aren't we? So we're under constant bombardment, and we don't make it easier for ourselves, do we? We don't get enough sleep. We don't exercise enough. We have terrible dietary habits. We take in things into our body that weaken our immune system. We surround ourselves in toxic environments, not just physical, but emotional and mental. So the immune system has a lot of work to do constantly. So where does it start? Well, actually your immune system starts with your skin, not just as a barrier. And of course it is. You don't run the risk of a skin infection or an abrasion or anything like that unless you compromise the skin itself. But also when we sweat is a great defense mechanism. And as we sweat, how do we sweat the most? Well, we can be in warm temperatures. But if we exercise is fabulous and a great way to support the immune system. Did you know that? Tears. They don't have to be sad tears. We can just watch something make us laugh so hard we cry. But sometimes it's good to cry. Did you know that? Yeah, to burn off those negative emotions, to get rid of them. And sometimes we're too quick to withhold that, to not take care of it. So our first level of defense is the largest organ system of the body. That's the skin. Did you know it was an organ system? There you go. Think of that as a question you may have to answer on a quiz. Hint, hint. So the first line of defense is the skin, the mucosal tissue, or the mucus. That's your mouth, your eyes, your reproductive system, and your anus, your elimination system. Stomach acid, if we take in something that's harmful to the body, many of those types of things are destroyed in the stomach acid. So that's our first line of defense, and it usually works pretty good. But sometimes it gets compromised, right? We breathe things in. So we take them into our lungs, and our lungs are a nice, moist, warm environment, and that's just about perfect for many pathogens. And sometimes we compromise the skin barrier, right? We get cuts and abrasions, and sometimes we make intimate contact with someone and we take on pathogens that way. Sexually transmitted diseases, prime example. And then our third line of defense, of course, are antibodies, our T cell and B cell moderated immune responses, our phagocytes, macrophages. That's a Latin word that means big eater. So these Pac-Man cells that go through and destroy things. And so there are a class of cells that eat up pathogens, as it says. But there are many different types. There are cells that they're responsible for something called keto apoptosis. And ketoatosis, which is, they produce chemicals that they inject into an invading cell and cause them to eviscerate, to break apart into pieces. Or they inject specific antigens into foreign cells that get into the body, and it causes a cell to self-destruct, and that's called apoptosis. Again, these sound like really good quiz questions. So immune cells. We have plasma cells, memory cells, antibodies, B activated, T activated, all these different cells. I don't expect you to memorize all these different things, all 9 levels of the immune system. But I would like for you to understand that this is an entire communication line. This is a communication line that's working all the time, and they communicate with each other with something called cytokines. You probably know them better as interleukins if you've read any science literature. So you have interleukin 1, 2, 3, 4, all the way up to interleukin 18. And now I understand there's 19, 20, and 21. We keep discovering more and more. You got to understand that this study of immunity and immune response is a relatively new science. It hasn't been around, it started probably in the late 1950s, but really picked up speed in the mid-60s to early 70s, and is really catching the attention of the scientific community from the 80s till now. So this is baby science by comparison, right? So Immune 1, it was formulated to support all 9 levels of immune reaction. And the biological function and how things react is based upon the level of involvement, the level of invasion, let's put it that way. First thing I want to talk about is beta 1316 glucan. It's a modulator. It modulates and modifies the activity of the immune system. How does it do that? Well, first of all, as beta 1316 glucans are introduced into the system, they have these small things called primary antigen attraction. So they have specific receptors or landing spots on cells. And as long as those cells are your cells, there's no negative response. But if those cells are not your cells, and how do they know, right? Well, when you take it into your body, into your system, it takes on part of your random RNA and DNA as cells break up and divide. So it understands who you are when you take it in. Isn't that interesting? It has biomarkers that identify indigenous cells. As it enters in and that cell ages, and some cells only live 6 to 10 hours, and then they eviscerate. When they eviscerate and break into pieces, those small pieces or immunokines are circulated through the body, and they attach to foreign proteins. Like what? Like viruses, like bacteria, all these things we'd shown earlier. So beta glucans identify the problem, but secondarily to that, it also stimulates primary macrophage activity, meaning that if there's a major invasion going on, it will prioritize and stimulate the larger immune cells to try to destroy the invading protein. So it's a very powerful molecule. It came about, there's a Dr. Deluzio, and then the late 1960s, early 70s, he had discovered the molecule and had made a very bold statement that this was how the immune system was stimulated. Well, we understood in the research that beta 1,3 glucan, which we find in oats, was very effective as far as gut immunity because it worked very well. It's found in oats, and if a horse or other types of cattle, if you added oats to their silage or to their feed, it would increase their gut immunity. and help them overcome certain problems. But the 1316 molecule was very specific, was not intestinally activated, actually was activated in the bloodstream. That was news, big news. I became familiar with this when I was doing some private research on looking at AIDS patients, and AIDS patients who had full-blown AIDS, but their partners never came down with any type of symptomology. In fact, they had no viral titers. You'd normally expect them to come down with something called ARCS, AIDS-related complex, but no, they didn't. And so, you know, it could be written off that they had a stronger constitution, which is kind of a, oh, how do I want to put it? It's probably a lame excuse for not knowing the real reason. What we did find out is many of these partners drank a moderate amount of dark beer. I wonder what that had to do with it. Well, dark beer has a heavier type of yeast component, and what we found out in the brewer's yeast, there was a very high quantity, rich quantity of beta-1316 glucans. And so I wanted to jump up and down. I wanted to scream and say, look, we found something to really stimulate the immune system. But the problem was it wasn't all that effective on all cases. It was tremendously effective on a few cases, but not enough to get excited. So the search continued. Arabinogalactans. Well, the story behind arabinogalactans, because these are found in plant form, right? Every formula we have is food derived and food based. So everything that you're seeing in this formula was actually derived from plants or from living, shall we say, plant-based products. So if you're looking at yeast and fungi, that's included in that list. So arabinogalactans, I went to this in the formula. I originally had gone to lactoferrins, which is drawn from cow's milk. Actually, it's drawn from the first draw of cow's milk. There's a lot of immune response and immune cells in the cow's first milk that's given to the calf to build up its immune response. Problem is, of course, there's so many people who are reactive to dairy products, and I really wanted as much as possible to go with an all plant-based system as much as I could when putting this formula together. As it turns out, arabinogalactans as a plant-derived substance are more active in the cells as far as stimulating cytokines. Now, again, remember, cytokines are those interleukin things. And what they do is they communicate, and they do chemical communication with one another. So they recognize that something is invading the beta-glucans market. The interleukin 4 cannot communicate with interleukin 10. It needs interleukin 6 to do it. It's an entire complex of chemical communication that has to be balanced. And arabinogalactans actually stimulate the balance of cytokine communication. Then I wanted something that would not only offer powerful antioxidation, but would remove and debride the area of unwanted cell fragments. Well, N-acetylcysteine, or NAC, it acts like a hormone in a ways because it's capable of stimulating metabolic activity of the immune system. So it enhances the immune response, which has already been activated. Now, you might want to worry about that a little bit, because a hyperactive immune system is why we have allergies and why people suffer anaphylactic shock from certain types of injections. But the good thing is that NAC is converted to L-glutathione, which is considered the master antioxidant of the body. But it also helps regulate T helper cell responses. What do T helper cells do? Well, Th2, Th3, and Th4 receptors are responsible for allergic responses and autoimmune responses. Because we don't want to make those hyperreactive, because people with certain types of arthritis would have an exacerbation. They'd feel worse. They would have more stiff joints, more inflammation. People who had allergies would have more severe allergies. That's not what we're looking for. So N-acetylcysteine, as it's converted to L-glutathione, is an antioxidant. It debrides the cell, removes unwanted things, and at the same time, it helps regulate the B cell, that is the cells associated with blood cells and bone marrow. It helps regulate the T helper reactions so that you don't have an overreaction. So that was a nice thing to add to the formula. D-ribose. Well, just the ribose should tell you that what? It's a sugar. So it D-ribose. Where have I heard that word before? D-ribonucleic acid, DNA. Oh, that's where it came from. It's provided to add energy to the defending cells on a mitochondrial level, on a subcellular level, so that within the organelle system of the cells, where there's the nucleus and the mitochondria and the RNA as it binds together to form DNA, all the reticulated cells and the monoclonal antibodies, all of these things that you had to learn in high school biology that you tried desperately to forget immediately. That's what this adds fuel to, so that your body's immune system can work most efficiently on a cellular basis. So this is not like putting something macro or something of a large molecular response. This actually gets down to the cytokines and the cellular matrix of your body. Interesting, huh? Sodium ascorbate. Well, you see the word ascorbate and you think, that sounds familiar. How about ascorbic acid? How about vitamin C? Well, sodium ascorbate is a buffered version of it. It also stimulates the immune system, and it increases secondary and tertiary immune cells, meaning the different levels of immune response. So when the first or primary immune cells become exhausted, you have a secondary and tertiary group of cells that come in as reinforcements. Sodium ascorbate also opens up hidden channels. I know you think in terms of bacteria being good or bad. Actually, that's not true. All bacteria is good. It's only bad when it grows out of proportion. Same is true with viruses. Every virus you've ever had, you still have. Most of the time they behave themselves. In fact, what determined your gender and what determined whether or not the egg was fertilized so you could be born was a virus. You didn't know that, did you? Sounds like another test question. So what vitamin C does, in this case in the sodium ascorbate, it helps open up the channels where specific pathogens tend to propagate and then take over in the worst way. Good example of that would be chickenpox. And as chickenpox sits there dormant for years, the immune system becomes compromised, and now you have shingles. So what does all this mean? I know for some of you, science just isn't your thing, but that's okay. Let's just keep it simple, shall we? How about this? If you're looking at your immune system, your lymphatic system, think of it as the pathway or the highway that many of your immune cells travel. Your tonsils and adenoids in your throat, that's one of the secondary lines of defense where these primary immune cells get to do their work. Thymus are T cells, right? T lymphocytes, thymus gland. And these to say, well, when you become an adult, that shrinks up, atrophies, and is no longer active. Not true. Not true. Thymus is active. It just becomes less active as you produce less and less ATP. Your appendix. We used to think of the appendix as something that was useless. No, it actually produces specific triggering enzymes that allow your body to fight against infection. Your spleen, of course, the spleen is like a dumping ground of old cells, cells that have reached their maximum use, right? Elephant burial ground, as it were. Well, as these cells come through, they're also carrying antigenistic signals that send out specific neurotransmitters and cytotransmitters, in other words, cell communicators. Again, they're cytokines, right? And they trigger the body's immune response. Pars patches in your intestines. That's your gut immunity. And that's really, really important. When your gut immunity is down, you are so vulnerable. And what can do that? Well, taking a long-term course of antibiotics would be it. Bone marrow. Your bone marrow produces the B cell moderated, and those cells are very powerful in attacking, I would call them the most aggressive forms of invasion. So I hope that helps. So a simple illustration, you have the invader, you have someone there with a camera. Well, that's the identifier, right? And that's what beta-glucans do for you. And then you have other cells around there that are ready to attack at any moment. Others want to remember what that antigen is for future attacks. And then they all lined up and surround the antigen and the foreign protein, and they destroy it. That's just how simple it is, except it happens millions of times per minute. So here's another illustration. On the far right side, you see a wound, right? Somebody scraped their skin and exposed the underlying level. On the outside, in the air and on your skin, are these bacteria, and they're looking for a place to live. Living on the skin is fine, but they're going to get washed off, and they're going to run into different types of resistance, and they're not going to thrive very well there. But oh, you open that skin up, boy, those bacteria will jump right in because it's wet, it's warm, and it's full of protein. What kind of protein? You. So there's an alarm that sounds. There's mast cells that are triggered. Platelets go to try to close the wound. These neutrophils are called out of the bloodstream. Those are the big macrophage cells that come out. And then the larger macrophages are sent to the rescue via what? The cytokines, the communication. Hey, we got a problem here. Somebody scraped their knee. And this could be something as simple as a scrape, and it could be something as devastating as a bullet wound. And that's the same reaction. And it happens all the time. Isn't that great? So pathogens. We're talking about viruses. There's just all kinds, right? Some are scarier than others. SARS, AIDS, certain types of influenza can be a real problem. But things like warts and things like, Ebola, that's real scary. Measles, all of these different types of viruses we've seen through history. Some are deadly, some are not. And what we see is that many of those that were once deadly suddenly become what? They become less of a threat. And that's because our body's immune system have changed not only defense against it, but changed the antigenistic expression of the virus. Bacteria. People used to die from bacterial infections all the time until we came up with the magic bullet. And the magic bullet, of course, is penicillin. Now we have a full family and several different legends of antibiotics out there that can help with it. The problem, of course, is as you take something to kill that bacteria, you kill all the bacteria. And you don't want to do that because that destroys what? Your gut immunity. There's fungi. Well, I'm not talking about mushrooms here. I'm talking about ringworm. I'm talking about ADV ammonia, candidiasis, yeast, histoplasmosis. Now, all these different things, you don't hear much of it, but it does exist there. And protozoa, we see those with like malaria. Protozoa is mosquito-borne spread typically, or through contaminated water. And then we're looking at parasites, roundworm, tapeworm, trigonosis. Most of those you get by eating usually raw meat. You have to watch out for that. Just read a study that said that the Japanese salmon is loaded with tapeworms. Well, Japanese eat a lot of raw salmon, so they're going to have to be a little more careful. And it's so easy to kill the larva of the tapeworm. Now, you don't have to cook it all the way through. In fact, you can marinate it for the most part and get rid of it. And then if we're looking at different types of proteins, and proteins in the form of, let's call them neuroproteins in this case, mad cow disease, and things of that nature. We really don't have a classification that works for that except to call them, aberrant animal proteins and antigens. So that's what could happen, and that's all around us, right? So as careful as you might want to be, you will likely be exposed, right? So what's the primary objective of Immune One? Number one is recognizing invading proteins and mark them for destruction. That makes sense, doesn't it? You can't fight a battle until you find the enemy. And then the second thing is to promote the appropriate cell response. You want this large macrophage here to reach out and grab the invading protein, envelop it, eat it, and destroy it. Doesn't that sound right? It does to me. Then you want to trigger the appropriate cells to grab, recognize, and make the invading cell part of your antigenistic immune response, so that the next time when it sees this invading protein, it recognizes it and destroys it immediately. And so if your immune system is sharp, that is to say, it's easily activated and maintained, most invading proteins don't stand a chance. It is when our immune system is compromised that we become vulnerable to the invasion of foreign proteins or proteins produced by the body that shouldn't be there. And then promote cellular debris removal. We don't want to leave these cellular fragments in there. We want to get rid of them. We don't want them hanging around. And many of them have genetic material. They have abnormal genetic material. And if that abnormal genetic material is replicated, it can replicate over and over and over again. And we call that cancer. So we don't want that around. Every ingredient is a substantial antioxidant designed to prevent and or regulate oxidative stress. And if you're looking at oxidative stress, what it is, bottom line is, if you look at all the issues that are going on over there, they're inflammatory. Oxidative stress increases inflammation. Think of oxidative stress as just a barrage of thousands upon thousands of fast-moving oxygen molecules that slam into mitochondria, slam into the cell wall, causing damage, changing the characteristics of the RNA, changing the characteristics of the tissues. And so it's like being in an internal hailstorm. And the body has to either kill the cell, destroy it, and or try to repair it. So by taking something that is strongly antioxidant, we reverse that process without the loss of cell activity. Who can benefit from Immune One? Well, anyone that is frequent colds, you know the person. You either live with them, you work with them, you go to school with them, whatever. They're coming down with everything that comes across the board. They've always got a cold. They always feel bad. They always have to take off work or take off school. They're vulnerable. And hanging around a person like that, you're exposed to more and more and more pathogens. Lack of sleep, lack of appropriate rest, that can compromise your immune system. Make sure you're getting plenty of sleep. Make sure if you're not, make sure you find a way to do so. Stress. Stressful relationships, if it's on the job or if it's at home, it's toxic. If you're constantly being barraged with negativity, guess what happens? Your immune system becomes compromised and you become vulnerable. So what about toxic food and drink? All you have to do is look at SAD, Standard American Diet. It's terrible. It's loaded with sugar. It's loaded with refined carbohydrates. It's loaded with junk food with absolutely little to no nutritional value. You want to eat healthy food, living food, food that puts energy into your body. And if you do that, you're actually taking the first step toward a healthy immune system. And then taking Immune One on top of it just adds that extra protection that you won't get any other way. Being overweight, carrying that extra bit of tissue around with you, for every inch of extra waistline is 28 miles of extra vascular tissue. The stress that carrying that extra weight does on your body is just unbelievable. The life expectancy and vulnerability of people who are overweight is through the roof. And then we all have to work on it. And if you need help with it, we have plans and systems in place that will do that. And then, of course, you can get a mosquito bite, right? And most of them are harmless. This one happens to be the Asian tiger mosquito that carries malaria and dengue hemorrhagic fever. There are mosquitoes here in the United States that can give you West Nile or the St. Louis fever or the New Orleans fever. These are all mosquito-borne illnesses. Can they kill you? Yes, they can. And so we need a strong immune system, and we need to take preventive measures to make sure we're not vulnerable to mosquito bites. More people die from mosquito bites than any other animal on the planet. Isn't that interesting? So do you have any questions? I'm sure you do. And I'm going to be asking you questions, by the way. So I'm recording this so that you can review this as many times as you need to. But feel free to contact me. Remember, I'm Dr. Stan Gross, and you can reach me at drstan@sanoglobalnutrition.com. Thanks for watching. You're going to hear from me again very soon. Bye-bye.